All right, it's news from Play Academy. We're here today with Zach Groshell. He's one of our learning science experts working with us on early math. And we're having a conversation today with him about what really matters in these early math grades. What is the knowledge and what are the skills that we're trying to develop for the kids in our apps? So, Zach, why don't you introduce yourself and then we'll get into the conversation?
Yeah, thanks, Niels. My name is Zach Groshell. I taught fourth grade mainly, but all the elementary grades for about 14 years. I started as a classroom teacher, working in various settings. And slowly over time, I started to develop an interest in how kids learn, how to design instructional sequences so that you can get kids who maybe don't like the subject to start to enjoy it, or how can you get kids who really are falling behind their peers, or maybe they are far ahead of their peers and they're just bored and they need to be accelerated. How do you create instructional sequences using technology, using curriculum resources, using existing learning science methods and approaches to accelerate all kids? And it's been great. I wrote the book Just Tell Them, which many people have read, that sort of described kind of my change in views as I read the learning science. And now I'm working with you guys. It's been a blast.
It really has been, yeah. So, one of the first things that I wanted to talk with you about today is why it's so important to lay that solid foundation of basic numeracy, basic operations, and math facts in these earliest grades, the youngest ages that we encounter the students at. So, kindergarten, first grade, second grade. Why is it so important that my child can do all these basic operations extremely fluently before we move on to any more complicated operations?
Well, in math, it's particularly important, but it's important across all the subjects. Math is what they call a subject. It's a subject that's relentlessly hierarchical. And what I mean is like it's very much like a step ladder across the entire curriculum. Everything that you learn, starting from very basic number concepts, just counting objects with your finger and making sure that your finger coordinates with the number that you say, and that the last number that you say is the final answer you landed on. All of that, all the way up through upper elementary topics like fractions and division and so on, all of those depend on the thing you were supposed to teach them before. And kids come to school often with just a little bit of informal knowledge about number. Even if you just kind of talk to your kid just minimally about numbers, they come to school maybe knowing that this group is bigger than this group, and they might be able to count up to three, but usually not that much more unless you gave them a little bit of formal instruction. Most kids that I encounter, even with a very rich math environment, might just know how to count up to 20 and might know a few very basic facts. But once you get into school, everything that you learn starts to become assumed in the next topic that you're teaching them. And the teacher in a heterogeneous traditional 30 kid classroom can only differentiate their teaching so much. Everybody makes a promise in that classroom that if your kid falls behind, I'll give them some help. If your kid's ahead, I'll give them a boost. But largely, it's a logistical challenge for teachers in that environment to provide any real meaningful support to kids who fall far behind, or for kids who already need to be accelerated, because you sort of have to teach everybody. You can't just turn your back on kids and put them in lots and lots of different groups, because then everybody gets less instruction. So the math is there's a reason why people end up, I think, saying that they hate math so early on. And maybe math isn't for everyone as a career, but it's a pity for me. But there's a reason why I think that happens so early on, and that's that kids start to flounder in the prerequisite skills, and they don't get up to a level of automaticity, or they don't know the material like they know their own name. And then when the next set of rules and procedures require that foundational knowledge, the kid can't deploy it very easily, and so they do that next more advanced skill much more effortfully, start to make errors, and they just start to fall behind, and it just becomes a vicious cycle unless you get foundational skills teaching like just right.
Got it. Yeah. So The challenge is almost to design a curriculum for those lowest grades that has no prerequisites, that can take any kid just from absolute zero to where they need to be for these next steps higher up the skill tree, as you neatly put it. So, what are those earliest concepts that you would try to get kids comfortable and familiar with in kindergarten or maybe even pre-kindergarten?
Yeah, they sound so simple, right? But when I put them together, but this is my world. I just love working with the earliest mathematicians. A lot of what you need to do is, because they don't even know the concepts that we all take for granted, is you have to be very careful with language. One of the things that we embedded in one of the apps that we've been working on at Play Academy called MathQuest is that a lot of the early math doesn't include language like equals or add or plus. They have words that young students understand, so that we can get into the math much earlier. For example, like if I'm going to have some numbers and I have to put them together, they're going to end up with a number. And so maybe that number, maybe you get more of that number, or maybe you get less of that number. And we use those words at the start to give students a referent to what will eventually be replaced with ends up with is equals, and gets more of is plus, and gets rid of or gets less is minus, and so on. So you, at the very beginning, you start with what the child already knows, language that they know, and then you give them a mathematical term after we've practiced the concept, and you're slowly building from a foundation of counting. Everything begins with the child probably knows how to count up to three, but we start by teaching them to count up to three, but then we add gradually a few more symbols, and we're counting orally and through the interface, different ways of counting different objects. It's funny what an expert like us can take for granted when it comes to teaching math. Like we just think we can really go fast, but at the early parts of teaching young kids, you go slow to go fast. You really nail number concepts, and then all of a sudden these little itty bitty pieces are put together into adding their first number sentence, and then eventually adding those numbers in columns, and soon we're into the math that we all think of as math, but the young math for young children is very carefully putting the little itty pieces together for a good 6 months at the beginning of the sequence.
Yeah, great. So what you said there about language and the importance of not having any jargon that is off-putting to learners, that even applies throughout your lifetime. Like jargon is always the enemy of learning. That is one of the principles of direct instruction, right? Our instructional philosophy. So can you tell our listeners a little bit more about direct instruction and maybe why it's so well suited, particularly to those young learners?
Yeah, so there are many different ways to teach kids that have been discussed, like different philosophies, and some have more evidence than others. And there's no approach that has more evidence for its effectiveness than direct instruction. Direct instruction, though, it has a little bit of a bad rap. Like it sounds icky to people, because it sounds like sometimes a teacher is like really hammering the kids with lots of really boring material, and it's largely the teachers doing all the talking, and the child is sitting back and receiving a lecture. And what we mean is the sort of the scientific definition of direct instruction, which is a very careful, interactive type of teaching, where the amount the teacher talks is often limited to about 9 seconds. We're talking about just a very quick thing, like here's a rule. This is an equal sign. You have to make this side the same number as this side. And that's all the talking that happens, but it happens up front so that the child can be successful in their practicing the rule, using the rule. And those rules or concepts that are explained very briefly by the teacher are often not, they're usually examples. Here's an example of this. Here's an example of that. Letting the examples show the student what success looks like, what a non-example of something looks like. And in doing this, you gradually move the student from being dependent on the teacher's guidance to the student being able to do it with no talking from the teacher whatsoever, but it's completely replaced by problems that the student just needs to practice so they don't forget the material. That you mentioned wording or the precision of how the words that are used, and this is a huge feature of direct instruction. If I just overload you with lots and lots of jargon that you do not know, and even things like if my explanation doesn't include the same words as the questions that I ask you, I suddenly change it up when I ask you a question. All of a sudden, I'm not going to get a lot of understanding. I'm going to get a lot of confusion from you. And that sounds like it's pretty obvious, but from our end of designing this stuff, that's really hard to get right because we know where you need to go. We know what the end looks like, but we need to make sure that every explanation, every example, every question, and every problem is in perfect alignment and that the words point the child in a way that makes this material just feel obvious, in a lot of ways satisfying. It's a lot like a really great video game in a lot of ways where you go from one level to the next and all of a sudden you look up and you go, I can't believe how much time is gone. And I've never felt absolutely frustrated, but I felt challenged and I felt supported. And I don't want to leave this environment because success is just driving me to keep on going and keep on practicing. That you want the
Yeah.
child to feel that way, not like they're that we don't want them to feel overwhelmed, but we want them to feel constantly at that perfect state of just being appropriately challenged.
Totally, yeah. We'll bookmark that gaming analogy for a little bit later because I think it's something interesting for us to return to. I think the way you described it here, it sounds to me like by having kind of a consistent structure and clear language, clear use of examples, counter examples, and also that continuous turn taking between the teacher and the student, you're creating a recurring, reliable environment that really reduces the external cognitive load, anything that could be distracting, that could detract from the learning for the student. And that enables you to focus on the content, right? Once a student has been through that lesson format a few times, it will feel completely natural to them. So in that sense, what can look formulaic and boring at first glance is actually a huge advantage, particularly for young learners who have maybe a more limited working memory and could more easily be distracted or confused by different types of lesson structure, different environments. Is that fair to say?
Yeah, and I think that in general, students and all children don't see clarity as being formulaic, right? They see clarity as kindness, right? They're like, "Oh, thank you for showing me this in a way that makes me feel really smart," right? When I hear something that just feels or sounds intuitive, I can quickly gain expertise. My motivation starts to spike. A lot of times students they and if you they're just like us. If you think back to the teachers of when you were a kid, there was always a teacher who was fun and whatever else, and it was just a great time to mess around for a period or two. But there were also the teachers that you went to when you really needed support, especially if there was a subject that you weren't very good at. I had a teacher who got me through a level of math that I had missed from being overseas and missing some school, and he just very carefully and very precisely would explain how to do things and immediately ask me to do those problems so I was in the math. And the whole time there, I might be thinking instead of, man, why do I have to be here and why is this so hard? But your all of your thinking and cognition just gets put on the math when you have a teacher who just really makes you feel involved and smart at all times. Kids, I don't think, see clarity and systematic instruction as being boring. They enjoy it. They enjoy it because it's satisfying to get better at stuff.
Yeah, absolutely. I guess one of the most common things that children will tell their parents when they're struggling with the subject at school is the teacher's just bad at explaining. I don't understand the explanation. I'm not getting sufficient instruction. And So to some degree, it's understandable. It can be very challenging to adapt to every single student in the classroom, find a speed and a format that will fit every student. But is there any other reason why you think traditional classroom, but also other ed tech, other types of teaching struggle finding that right balance of instruction, practice, and especially the interactivity of the instruction? So you don't just sit there listening to a lecture for, I don't know, 15 minutes, and by the time you're supposed to do your problem set, you've already forgotten everything that was said during that lesson?
I mean, teachers in a traditional setting have almost an impossible job, right? And it's not their fault. I know that I know what it feels like as a teacher to have all of these various responsibilities and a huge array of different abilities, and basically be told you need to meet the needs of all sorts of kids. At the very beginning of kindergarten, that problem doesn't go away, but it's actually lessened by the fact that most kids don't have that many formal learning experiences. But very quickly, as we know, math is like a step ladder. Very quickly, as you go up the ladder and go into the next grade and the next grade, every student that just didn't get sufficient practice in the material because they needed more trials, they needed more repetition, those students start to fall behind. And the students who got it first time start to really find the material to be far too easy. And so the teacher has to make choices. Do I teach to the middle? And that's because that's most of my class. Do I teach to the lower students or lower ability students because that's in my value system? It's extremely important to help kids who have a rough time, or we want to make sure we don't create a gap between students. Or, and usually that's the decision right there. And then the students that are on the side of needing more acceleration to enjoy their math class, we hand them a worksheet or something and say, hey, go over here. Maybe here's some extra homework. And of course, parents love that, right? The kid comes home with a big stack of homework that now the parent has to teach them, because you can't just do a worksheet without any teaching, right? It's a very tough job, and it's an impossible job. One of the things that I'm so happy to be leaning into more and more is just the growth of AI, the use of one-on-one technologies, but in concert with learning science. Because other apps in the past have really optimized for entertainment. They've optimized for just making it's a lot like if you've ever tried one of those language learning apps and you feel satisfied every day because you're getting points for it, but you don't really feel the whole time that you could go and speak that language. And then when you go to Mexico, that you didn't even learn the most basic
Right.
things. A lot of apps were optimized like that.
Yes.
And so no more, right? We can get the benefits of one-on-one technology, and we can blend this with the best that we know about how kids learn, and we can make kids learn twice as fast doing that.
Yeah, so that's exactly what brought us together, right? Zach Groshell and Play Academy. The belief that direct instruction as a pedagogy is actually extremely well suited to being converted into a software format and being delivered to students through gamified interfaces that still carry that same pedagogy that Engelman and his disciples designed very carefully and deliver it at scale to millions and eventually billions of students around the world. So when you were describing direct instruction and what it actually looks like, it sounds already pretty algorithmic, almost procedural, right? It's in some weird way actually a pedagogy that is both extremely effective and well suited to being delivered through software.
It's crazy, but at the time that these programs, these DI programs that were using this research and were using this methodology in these apps, at the time that they were being developed, there were a lot of sort of workarounds that were created to make it so it was suitable for classrooms, including giving teachers like really scripted materials that they would use, and using lots of like whole group responses because you had a large group. But the whole time that direct instruction was being developed, and I say this because I just happened to be at a conference about this and we're talking about this. The whole time it was being developed, there was always an eye on how can we use technology like video discs, how can we use computers to basically take these very careful little threads or tracks and strands and allow the computer to deploy these really fantastic scripts and insights that have been developed by working with kids. If you think about it, teachers are what humans in general, it's very hard to keep an explanation tight and concise. Even in this right now, I'm going off on all sorts of tangents and I'm making it hard for the listener to follow my train of thought. But when it comes to a device, it has unlimited patience. It has no problem deploying that perfect explanation, that perfect example, exactly right 100% of the time for the next infinite number of years for infinite number of students. One of the advantages of using these devices is the things that really need to be careful and precise that often humans are just they're just not good at doing that because we have a tendency to improvise and get off track and lose our train of thought. Devices do those things perfectly, allowing humans in the loop, the ones that are helping their child or teachers that are using this in the classroom, allowing them to lean over and ask how you're doing, ask if how what progress you're making, help you with goal setting, help you with things that are probably best suited for humans to do. So I think it's sort of a partnership, a marriage of what humans are really good at and what computers can do just much more efficiently and effectively every time.
Right. And one of the interesting things to realize is when we're taking these direct instruction scripts and transferring them into software, the individual student experience actually ends up feeling very personalized because we can take that script and just branch it out in all the different ways of if a student made a mistake here, what's the correct feedback that they need to receive at that point. If you go further up the skill tree, like, does the student getting something wrong here actually mean there's a hole that we need to go back to and fill? So what looks kind of formulaic and one size fits all from afar, actually, if you observe an individual student go through it, it really does adapt to their particular
like learning profile. You're right. They develop a profile of their skills, and as the student indicates that this is going too slow for me, I'm getting 100% of this correct, I'm suddenly moving a little bit faster, but it's invisible to the outsider, right? But the same happens to a student who just needs more practice and just very carefully, gradually faded instruction. That fade and the amount of practice is there without making the student really aware of it. There's a lot of empathy, I think, in this, right? Where if you're
yes.
in a traditional classroom, you notice that people are pulling ahead of you and you feel like you're constantly in competition with others. And especially if you're just right on the edge and you're feeling like you're on the bubble and you're just always falling behind the kids next to you. In this case, you're given extra practice and nobody points their finger and says, ha, you get more practice than us. It just lives in the ecosystem of your learning app. And so there's a lot of empathy, I think, in designing this in a way that's private and
Yes.
honors students' own learning profiles.
Yeah, I love the term learning profile because there's this gotcha thing that people like to do in the education and learning space around learning styles, where whenever anyone brings that up, it's like, ha, gotcha. That's not supported by evidence. There aren't actually multiple learning styles. But the intuition or why parents or educators might believe in it makes sense, right? Like you see students in your classroom or you see your kids and you realize kids are different. So something in here should probably be personalized. And then that is conceptualized as a learning style. That conceptualization may be wrong, but the realization that students learn at different speeds, make different kinds of mistakes, need targeted feedback and remediation is totally correct, right? So the challenge is to take the instructional design, the way of teaching that we know works the best, and make it individually responsive to each student's state of knowledge, where we want to get them, and how quickly is it realistic for them to make that amount of progress. So learning profile, I actually love that term. I think we should go with that in the future.
Absolutely. And I think I'll make a note of that if we have time for parents, because you mentioned learning styles, and learning styles is really the belief that different students learn best if you give some of them like visual math, others auditory math, and then others even maybe they play with or drag and drop objects in math. And that will help students based off of some sort of test we give them that identifies that learning style. It will help accelerate that child if we make sure that the app caters to that learning style. And we could easily do this, Niels. We could remake our MathQuest app
Yeah,
around
absolutely.
this scheme. The problem is that the whole thing isn't true, right? It's not a scientific finding. And the truth is what we do with, for example, the app MathQuest is in accordance with the science, which is that students require a very careful blend of those modalities dependent on the specific math topic that we are teaching them. So you will see using a really great app like MathQuest, you will see activities that involve visual stimuli, auditory stimuli, and a kinesthetic stimuli using the interface that are always blended together. Just think about different topics that children need to learn. Can I teach someone to count an object without having them move their finger and use and dragging and dropping objects? I can't just teach them with a visual, and I can't
Yeah,
just teach them auditorily. At the
yeah.
same time, there are a lot of things that can just be explained with words, right? And so the what a great designer does is thinks just very carefully about the content and provides the right stimuli and level of support, visuals, auditory supports, and kinesthetic supports in tandem so that content just becomes very clear and obvious to the kid. But we don't learn about children's profiles because we're all of those learning styles, right? But some of us go a little bit faster than others, and some students need a lot more support than others, and that's what we optimize for.
Yeah, exactly. Every parent out there who has the feeling my child needs a unique approach to teaching is completely right. It's just learning styles aren't the answer. It's the specific amount of instruction that is needed to get them to the next point, and the interventions if they develop misconceptions or just don't get something the first time. That is what needs to adapt to the individual learner. And I love what you brought up there, how we are actually very multimedia by design, where we have auditory, visual stimuli, we have kind of interactive modalities where you have to drag and drop something or respond in different kinds of modalities. And I think the reason why all of this comes together so particularly nicely in the Playcademy apps is what we've done in constructing our team, where we have you on board bringing in your direct instruction expertise and your curriculum design. And then we have game developers and designers from the gaming industry and people who are very experienced with multimedia and applying all that to give the level of care and attention to direct instruction that it probably deserved all along, but finally putting that into one great integrated experience and starting with the youngest learners. So I'm just curious what that process has been like for you to work with people from a totally different background and see them bring your ideas to life and develop a very beautiful and gamified interface around that.
I think the interesting thing about doing this, and it's been extremely enjoyable work for me, but the interesting thing about this team is we all expect each other to learn about each other's specialties, right? Right now, as a non coder, I'm spending lots and lots of time mocking things up and building things with the new AI models, and something I never would have needed to do previously, and learning all of your jargon so I can communicate more flawlessly with you. And at the same time, all of the engineers are reading learning science books and staying up to date when it comes to social media on what are the trends in education. And doing so, we don't create like all of these specialized roles where we have to constantly communicate things to each other and we make lots of errors. We all overlap like Venn diagrams with our knowledge, and in that way we can really make it collaborative. Like what I do is I sit and I think about the universe of knowledge that needs to be taught, and I think across that knowledge to grades that are even not represented in our apps, and I start thinking, how do I lay the foundation so that I'm not creating problems down the road that another app or another teacher is going to have to undo because I wasn't careful enough with the instruction. And I think across the different strands, I think vertically, I think horizontally, and I'm looking at all these details, these just very picky little considerations about how the instruction is done.
Yes.
And then when I bring those ideas to an engineer or to a developer, those ideas are honored because they make sense. They're like, yeah, I can't believe that what we had before, it was okay, but V2 of that same thing is just shorter, more efficient, and much clearer for the student. So it's just been a blast, really.
Yeah, awesome. Yeah, and I can only echo that. It's been a very fun experience to put that all together. And I think we've truly made a difference, especially for those K through 2 or 3 students. Because if you look at kind of the space of other apps, other programs that is out there, for example, Math Academy, one of the most respected names in the game with a very sizable curriculum and very careful instructional design, they only really start their curriculum at 4th grade. And then for the lower grades, there are alternatives out there. A lot of them just don't look like they've been treated with the same level of care, either on the instructional design or just the quality of the interface. I find that actually quite surprising. Do you have any hypotheses around why, for example, Math Academy doesn't treat the lower grades, or why there hasn't been a product specifically in that space? Especially given that we've set laying these foundations that lead to automaticity with the more complex operations later on is so especially important.
It's because it's way harder to design, right? That's why. The truth is, as you get older, it seems like because you can read, because you know all of the language from whatever your past experiences are, both pertaining to the math and academically shaped language. Like school, you know what a question sounds like. When they say identify the prism, you know it just means touch the prism, right? As you get older, your ability to extract a lot of meaning from static text, from static diagrams, just basically giving students a very minimal sort of worksheet on the screen. Most students can read what it says and study the example and answer the questions. But just put yourself in the shoes of a younger child. They can't read the answers in a multiple choice question. If you give them a diagram, if you know any child, if you've ever been around a kid once, give them a diagram and say, study it and make meaning out of this. Their eyes are going to be darting in all sorts of unproductive places, and they're not going to make generalizations and find patterns that way. They need a very careful step-by-step approach in which, when they're taught, something on the screen shows them, but not while talking at the same time. A very careful, continuous conversion type of approach where I give you a little bit, I transfer it, I give you a little bit more, I transform it. Children need very careful tactics in the younger grades, which requires us to do a lot of artisanal and sort of manual correcting of what is possible out of the box sometimes with AI. And that work is tough. It's tough to work with the youngest children's interfaces and interactive materials because of those reasons. Even though the math is much simpler for us, it just doesn't make any difference. The math is simple, the tactics have to be much more precise. That's my hypothesis on that.
Yeah, I think that makes a ton of sense. Just surveying kind of the products out there, one of the main first things we realize is just the over reliance on having students be able to read, which just doesn't make any sense if you're talking about kindergarten or 1st grade or 2nd grade students. And once you find a solution for this problem, it actually enables a couple of things. Students who are behind on reading, and thus probably also behind on math, because in other programs that will require some ability to read, can now catch up, right? But it also means that kids who are potentially much younger can already get started with our kindergarten or 1st grade content because it doesn't require these other skills, and it has been designed so that it's really appropriate for the age group. So would you agree with me that there are probably some 3-4 year olds out there that could already start interacting with our kindergarten and 1st grade materials?
Absolutely. And here's an example. And this one drives me crazy, right? We all know that word problems are a struggle for many kids. So we know that we need to expose them to word problems, teach them how to attack word problems, and we need to get them as soon as we can into word problems in their journey, right? And so, because of that, many math apps, many curriculum resources, and textbooks put word problems in front of non readers and have them read them. That sounds pretty absurd. You wouldn't think if I'm creating something that's systematic, I'd ever put something in front of a child that they just absolutely couldn't do. And then there's workarounds. The child's meant to click the little audio button and then it reads it to them, right?
Yes.
But already too, there are just a lot of sentences in many word problems, and young children can't deal with too many words spoken or written, right? And like in our app, when we are approaching word problems, we give children word problems very early, but they're just not written word problems. They're oral word problems that have just very careful prompts, and the child responds with, for example, Dan has 5 apples. He gets 4 more apples. How many apples did he end up with? And the child can answer a ton of questions. Is he getting more apples or is he getting fewer apples? Is this a plus problem or is this a minus problem? They can answer questions like, and then finally, he ended up with 9 apples. Go ahead and solve the problem, and they can work the problem. And they can do all of that without reading lots of text. And of course, we want them to read text, but it's all about sequence. Once they are at an age in which they've mastered the beginning squiggles on the page, their phonics, their letter sound correspondences, the words start to increase on the screen, and students start to read things that are pretty easy for them in math. But math should not be a language test, or and much less, it shouldn't be an IQ test. It should be a math test, right? So we need to make sure that before they can read, they are exposed and mastering math that later on will be represented with words that they can read from their reading class.
Yeah, absolutely. Your math skill tree shouldn't have some reading checkpoint that is needed early on that just blocks progress for children who haven't cleared that yet. I think the proof is in the pudding. Our apps have been designed to not have that prerequisite there, and I think we'll see a tremendous amount of success with getting very young learners up to much higher math levels than has been possible before because of that. One thing I would want to end on, because I think it's something that we haven't addressed yet, but will be pretty obvious for anyone looking at our apps and comparing them to what else is out there, it's just our use of visuals that are reminiscent of video games, our use of kind of engagement features like streaks or other features designed to keep the student coming back and engaging with our content. And to some parents, that might look like we're doing this typical grab for the kids' attention without providing any real value, right? So let's turn that on its head and ask the question, once you have an efficient pedagogy and that's delivered well, is there any reason your app can't be fun for kids?
and this is great, right? So learning first, right? And then second, can't we make an app that kids want to spend their time on? Can we make an app that feels like I'm immersed in something, and also that coaches me to get better and to be my best self, who quietly teaches just the way that mathematicians interact and think about the world? Can't we embed these just very carefully, just like we did with the learning design? Can't we have a kind of emotional design that's layered into the app through the visuals and so on? Of course you can, right? And I think that it's important for students to enjoy what they're doing. There's going to be times that students it's just like going to the gym. It was fun afterwards once you feel like you've hit the weights and now you feel healthy. But during it was pretty strenuous because you had to lift all that weight and it just you weren't feeling like it. But overall, think about, even with that same gym metaphor, that maybe I'm extending it too much, but just the people that you encounter, and how does this stimulate me to be my best self and to feel like I'm part of something? And that might sound all grand, but like, for example, in MathQuest, I really wanted to create an experience that felt like you were going on a journey. And
Yeah.
that's not, and that importantly, it fits with both kind of traditional girl and boy roles in the sense that this isn't catered for specifically for boys, which it feels like many apps are designed that way because of various reasons. I wanted this to be for everyone. I feel like I'm going on an adventure, that I'm collecting things. It may be like some of our favorite adventure games like Zelda. I'm sitting around the fire. As I camp and as I go along this journey, the environment gets more complex and more interesting, and worlds become more foreign. All of these things play a role, I think, in for some kids, it's why they come to the app. For other kids, it's just an enjoyable part of why they say I love Math Quest, right? I love seeing my progress, and I feel like it's helping me know by wayfinding what I need to do and what I need to do next. Maybe kids approach that with various sensibilities, but at the end of the day, that I think that a great app thinks about everything and doesn't ignore the fact that there are motivational benefits to making a very high
Yes.
quality premium experience.
Yeah, these are metaphors that are commonly employed, right? Learning should be a journey of discovery or a great adventure. So we thought, why not make that actually explicit and bring that to life? And if that's some kind of ethos that kids can absorb through our apps, that the point of learning is to build your character, become more powerful, more potent, more knowledgeable about the world, and be able to therefore do more things in the world, then that's just an additional benefit. It's something great that we've instilled in the kids that they will hopefully be able to keep as a way of being even after they're done with our Play Academy educational journey with them.
Absolutely. I think if I could even just push on this for one more note, it's a lot for my daughter. A lot of times the books that she chooses off the shelf really are about the cover at first. And we all tell children it's the book, it's what's on the inside of the book. Don't judge a book by its cover, right? But also, like, when she pulls down that book and she feels it in her hand, some of these really beautifully designed kind of books, and she looks at the cover and it inspires her to read the back, it inspires her to read the inside. And then as you're reading it, this is a book I want to hold in my hands.
Yes.
There's other books I don't want to hold in my hands. What's most important are the words on the page. However, other things are important when you're thinking about the premium and features and the features of a really great experience that's more holistic and can really grab the attention and the learning of more kids than we ever thought possible.
Yeah, I'm so grateful that I've been able to be a part of this and work with you and our amazing game developers to really build that first of its kind in the category, a learning app that is very efficient, designed with evidence-based learning science at the heart, but also built with the care that a product like that deserves, made to look and feel like a truly handcrafted premium product that is just fun to be in. So it's been great. It's been a blast. Thanks for talking to us today, Zach. I'm sure we'll have you on again in the future. And thanks to everybody listening. I hope this was a little bit educational and also a little bit entertaining, just like our apps try to be.
Thanks, Niels.